In this video, we're going to calculate the Cronbach's alpha, or simply the coefficient alpha of an instrument, which is a 5-item questionnaire with Likert type scale. The scale is from 1 up to 7. So, assuming that we have encoded the responses of the respondents. So we are looking at them right now. So I'm going to simply copy. Then I'm going to place the responses on a worksheet. Okay. So we are being asked to calculate the Cronbach's alpha or coefficient alpha of the instrument. So remember, we're calculating the coefficient of the instrument and not these responses, not the coefficient of these responses, although you can say that we are basing our computations on these responses. We are after the consistency reliability of the questionnaire based on the responses of these 15 persons. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we have 15 persons. So we have these items, item number 1, item number 2, or question number 3, question number 4, question number 5. So we have our worksheet. So let us take a look at the formula for Cronbach's alpha. So here is our formula. So we have n divided by n minus 1. N is the number of items in the test. The number of items in the test. Now, let us take a look at our instrument. Our instrument is composed of, our questionnaire is composed of how many items? 5. Q1, Q2, Q3, Q4, Q5. So that is our n. N is equal to 5 items. So in our formula, you have here n. So this is 5 items divided by 5 minus 1. So you have 5 divided by 4. So that's easy. So how about this S sub t squared? We know that S squared is a measure of variance. But variance of what? So below, S sub t squared is equal to the variance of total scores on the test. The variance of total scores on the test. So let us calculate the total score for each test. Okay? So, no, not for each test, but the total score for each respondent. Okay? Then we will get the variance of that. So, let us go to our worksheet. So, I'm going to label this as total score. Okay. Total score. So the total score for person number 1 is simply the sum of from cell B4 to cell F4. So let us just duplicate this formula. So the total score for respondent number 2 is 24. The total score for respondent number 3 is 18. And so on and so forth. The total for respondent, the total score for respondent number 15 is 18. So again, let us take a look at the formula. So this S sub t squared is the variance of total scores on the test. So we know how to calculate the variance using a built-in formula. So let us do that. So this is equal to variance, the sample variance of the total scores. So 22.209 in our formula, that is our S sub t squared. So next, what is this summation of S sub I squared? So we need to get the variance of each item. So S sub I squared is the variance of an item. So we need to get the variances of all the items. So let us do that. Let us go back to our worksheet. So let us calculate the variance for item number 1. So let us place it here. So variance, the sample variance of item number 1. Next, the sample variance of item question number 2 or item number 2. Or I can simply duplicate the formula to get the variance for item number 3, variance for item number 4, and variance for item number 5. So this is S sub 1, S sub 2, S sub 3, S sub 4, S sub 5. Then we need to sum up all of these variances. So let us take a look at the formula. So you have the sigma symbol. So we need to sum up all those variances. So let us do that. Sum up all the variances. So there you go. You have this sum of all the item variances. So in our formula, this is it. Now for the denominator, we have already computed that. S sub t squared, that is equal to 22.2095238.1. So we can now calculate the Cronbach's alpha coefficient. So I'm going to insert a symbol alpha. Where is alpha? And equal. This is just a label. Again, this is just a label. So for our coefficient, so let us calculate. Let us do that. So what is the formula? N divided by n minus 1. Our n is, how many items do we have? 5 items. The questionnaire is composed of 5 items. So you have Q1, Q2, Q3, Q4, Q5. So 5 over 5 minus 1. So 5 over 4. So 5 over 4 times. So this is the variance of the total scores. So that is the variance of the total scores divided by no, minus sum of all the item variances minus, where is that? So this is the sum of the item variances divided by the variance of the total scores. So where is that? 22.209. Okay? So an alpha coefficient will not go over 1. So I have made a mistake. So I'm going to check my formula. So, oops. So I need to enclose this whole expression in a pair of parentheses. So G20 minus G22 over G20. So what is wrong? What is wrong with my calculation? So n, 5 items, n minus 1. So total scores and then the variance. So what is that? Total score, sum of B4 to F4. Let us do that again. So it's not changing. G4 to G18. So how about this one is variance from B4 to B18, and then I duplicated the formula and then I totaled it. Then I calculated the coefficient. No. So okay. So the formula is wrong. So I need to enclose the numerator, the entire numerator. So look at the formula. I'm going to enclose this in a pair of parentheses, or otherwise, since the computer is following the hierarchy of operations, just like in algebra, the computer will divide this with this and not the whole of this numerator. So we need to enclose this whole in a pair of parentheses. So let us see. So the Cronbach's coefficient is negative something. So this is not a good coefficient. This is not a good coefficient.